how LLMs can enable science to have greater impact. We know that science has always played a very important role in solving important problems in society. But one of the main challenges of science is that science has, always been traditionally a process that occurs in a silo. So you have the scientists who do the science, they do their research. Many times it's basic research. They publish papers to share those results. Most of the publications produced by scientists are read by fellow scientists. They are not read by the people who actually develop solutions. And so because of this, it's actually incredibly surprising that in the history of science, it's always been a huge lag between when a new discovery is made to when the discovery is actually translated into the clinic or into society. If you take in medicine, the Chinese used artemisinin for over 200 years before artemisinin was isolated and used as a treatment for malaria. And artemisinin today is the most effective therapeutic against malaria, and yet it took more than 200 years before the translation occurred. Can we make that translation of science from discovery to practice instantaneous? Can a new scientific discovery be translated immediately? And the way to do that is to make tools that bridge the divide between those who do science and those who develop solutions. So those who implement solutions can include governments, they can include investors who give money. They're not going to read the scientific papers that scientists publish. And so it takes a very long time, for scientists to hope that one day somebody will take my discovery and translate it into the clinic. And so that's why we're really excited by this. We are taking this huge vision into something that we believe is solvable, because today we are at the point where computers are beginning to understand, in quotes, human language. And human language is very essential to how we work across society. And unfortunately, we all have our own silos of expertise. So if I'm an engineer, I don't talk to a physician. And yet, the solution an engineer develops could actually impact the work of a doctor, right? So can we build tools that bridge across divides? And this is where I think large language models come. So to be more specific, our goals are to demonstrate that, using LLMs, we can contextualize scientific information into a way that people who are not domain experts, they can use that information to solve their problems. And their problems could be, should I build a well in this part of the country based on the scientific knowledge we know about the climate of the area, based on the knowledge we know about water, based on rainfall or weather? Can we use all of this information to solve this problem without calling a scientist, without hoping that I'll be able to employ some scientists to do it? So that's one. So how can we take that knowledge from scientific papers and then translate it into a way that non-scientists can use it? The other one is, at the heart of science has always been the idea that science is informed by evidence that is derived from data. But to derive evidence from data, often you need to do some analysis on that data. When scientists publish papers, their scientific output comes in two forms. So it comes in a paper that is basically written in natural language, right? But also it comes in the data. The paper is sort of a synthesized version. It's actually in many ways the scientist trying to tell you a story. And there's always a danger in a story that somebody is telling you, because they may not be telling you the entire story that is actually in the data. They pick the best story that fits their objective. So because of that, can we use AI tools to automate how we analyze data? Every one of us has questions that could be solved by data, even when we're not scientists. You might be interested in deciding which crop should I grow in this place based on the rainfall patterns, the soil requirements of that crop. How can I use all of this knowledge to decide which crop to grow? So I can answer that question using data, right? Scientists, in fact, are trying to research this problem in many different ways and they write papers that, mostly are not read, right, by most people because there's so many papers being published. So can somebody who is not an expert but just wants to, decide what crop to plant, use this data to answer the question? And LLMs can help in this because LLMs, with understanding of natural language, could potentially interface between a non-expert asking a question and the LLM would figure out, okay, this is a question about data. I need rainfall data. This is where I get rainfall data. This is the kind of statistics I need to do to decide which crop is optimal for this climate, for this soil type, and then give that as an answer back to the user in a way they understand. And in this way, non-experts can use scientific evidence in real time instead of relying on synthesized knowledge by scientists, which is not only slow, but also is not always, you cannot always iterate on it very quickly. And I am a scientist myself. I'm passionate about science, so I'm not trying to say that science is bad. I am very passionate about science, and that's my first area of interest. So we have broken these big goals again into two tasks. And James did a good job describing these tasks. We'll go over them, and we'll be there to assist the teams to go through this over and over again. Yeah, but basically in terms of it, the specific of the task is that we'll challenge you to develop an LLM-based tool that can take in one or more PDF scientific papers, and when prompted with a question, can contextualize the response based on that scientific paper. So you can imagine somebody who's not a scientist wants to understand a scientific paper and how it applies to their problem. Can they use an LLM to interface that? And from a technical perspective, we know this is an exciting area of LLMs because when we build LLMs, we train LLMs on vast amounts of knowledge, right? And because of that, they tend not to be very good at specific domains. So can we customize LLMs to specific domains so that they can perform tasks that are specific to those domains? And from a technical perspective, retrieval augmented generation is a powerful tool in doing this. So basically challenging you to leverage retrieval augmented generation to do this, and also to play around. We want you to be innovative. So if you see, there are parameters of retrieval augmented generation you can change, please change them, please play around with them, because that is how innovation happens. And this is how I believe that a small startup can develop a tool that outperforms the latest version of ChatGPT, because for one, you can build on top of ChatGPT. For two, you can contextualize it using your local knowledge that ChatGPT doesn't have. And three, you're not trying to compete with any one company. You can leverage models from multiple companies. And we know that, when you combine many models, often you get better results than one. And in fact, we know, from some benchmarks that if you combine several open source models, sometimes you get better performance than a very expensive commercial model like the latest version of GPT. So we'll provide you with some documents to do this. We'll provide you, some questions to see how your system works. And then in task 2, we'll shift from just trying to contextualize LLMs to use to contextualize responses based on provided knowledge in form of text. We'll challenge you now to use LLMs to interact with data, because data, is the primary source of knowledge. So the idea is that, you can have tables, right? And you have a large table that has many items, and you want to know, what's in those tables. Maybe you want to know even more details, you have some crops that grow under different conditions with different rainfall requirements, And somebody wants to ask, what is the average temperature at which this crop grows in this region of the world based on the table? To answer that question, you should ask a data scientist. First of all, you have to talk to them, right? If you are the one who is interested in the answer, you have to talk to them, you have to explain to them, then they have to do like an analysis, and a lot of things, believe me, is lost between, trying to do that. So this is why we are excited by this, that can LLM tools automate some of the processes we use to generate insights from data, and then importantly, take the output and communicate it in a way that is understandable to a non-scientist. And so we'll challenge you to do this. I know it can be done, and hopefully we'll figure out how to leverage some of the tools that have used it. And we shared some of this to do it, so it's not a pie in the sky, but of course we want to shoot for the moon, right? So we can land somewhere great. So for that task, we'll provide you data sets in a table format, and this will be the focus of day 2. So on day 1, we want you to focus on the first task, contextualizing LLM responses to provide knowledge in forms of documents in PDF format. And then on day 2, enable LLMs to interact with data. And then, on day 3, you'll have part of the morning to continue refining your solutions. And then we'll show you where to submit your solutions, which will be the code. So all the teams will have access to a programming environment called DeepNote that basically is like a notebook. So if you use notebook, it will be very comfortable to use. So you all have workspaces in that. And our colleague Stan will do a demo of how to use DeepNote. So that will be one of the key resources. And then also, we'll give you access to a platform called Together AI that has an assembly of hundreds of LLM models that you can choose from. So this will be a way for you can easily play around with multiple models without having to install each model, figure out how each model works, figure out like different API keys. So this will make it much smoother and also open new ways of innovating. So for instance, like combining models can be made very possible. When you have access to multiple models, you can combine them and see whether you get better results. So we hope this will be a very exciting experience. More importantly, we want you to form collaborations. So this is partly like, it's partly, you can say, it's partly research. So you should be open to like, new ideas, new paths. It's like you're going on a journey. You kind of know the destination. But sometimes you have to change the path, right? And so we'll be very open to that as well. So thank you again. And if there is one or two questions, and then after that, we'll have our keynote speakers. Thank you.